Hey, good morning, Pirates. Wanted to do a real quick discussion of the phase change lab. So those of you that haven't done it yet, if you have questions or if you're stuck, you can watch this and I'll kind of talk you through it. The first thing it asks you to do is identify your independent and dependent variable if this is your question. And so our independent variable would be time or time heated, and our dependent variable would be temperature. And then I'd ask you to go ahead and predict if temperature will increase steadily or not over time as you heat ice until it boils. And so you could put the temperature will show a steady change over time, or the temperature will not show a steady change over time. And then if you want to try to represent that with a draw tool, show what that line might look like as you graph it. Then it asks you to write a hypothesis. So here's a potential hypothesis. If water is heated over time, then temperature will not increase at a regular rate. Temperature will not change as the water is changing phase. That's a prediction you could make. And then after we've collected data, you could see whether or not that was correct. The procedure we followed, again, if you're at home, you did not follow that procedure. You watched this video. At the end of video 1, there is a data table like this that I filled out, and you just plug in the data and the observations, and then you use that to graph it. So this is what your graph might look like. You can see that I've inserted a picture. My title is the effect of time on temperature of water as it's heated. I have time on my x-axis with minutes as the units, temperature on my y-axis with degrees Celsius as my units. Then I have this line that starts out flat. This is where I still have ice. Once the ice is all gone, the temperature actually starts to increase because that's the water heating. And then once the water gets to a certain temperature, it starts to boil, and the temperature stops changing as it boils away. And so your graph should look something like that from the data that I provided you. Okay, the post-lab questions, just trying to understand phase change and the vocabulary that goes with it. When heat is applied to a material, its change in state typically goes from solid to liquid to gas. There are exceptions, which we would call sublimation or deposition. When a material is cooled, it goes in the reverse order, so gas to liquid to solid. Name the changes. And so when we go from a solid to a liquid, that is melting. A liquid to a solid is freezing. A liquid to a gas is evaporation, vaporization, or boiling. A gas to a liquid is condensation. A solid to a gas, so it skips the liquid, is sublimation. And a gas to a solid, skipping the liquid, is called deposition. This next analysis piece, it asks you to actually label ice, water, and steam on this graph. And so to do that, I did a screen snapshot of this, Command-Shift-4, and then I opened a draw application and I inserted that picture. Then I made text boxes for ice, water, and steam and inserted them, as you can see. And then I did Command-Shift-4, took a screenshot of this. I went back to my assignment and I inserted the picture with the labels. This is where I have ice. The ice is melting. This is where I have water. The water is heating. Excuse me, the melting would be this flat line. This would be ice just getting warmer. So like if it was negative 30 degrees Celsius, warming up to 0 degrees Celsius. So at that point, it can start to melt. And then this is where I have all gas, which we would call steam. What two states of matter are found during melting? Solid and liquid. What happens to the water temperature during melting? It stays the same. It's a flat line on the graph, no slope. According to the graph above, what's the freezing temperature of water? 0 degrees. During the liquid phase, water is heating, thus the temperature is changing steadily. What two states of matter are found during boiling? Liquid and gas. What happens to the water temperature during boiling? It stays the same, a flat line on the graph with no slope. According to the graph above, what's the boiling point of water? 100 degrees. To change phase, one must add or subtract energy. So if we put the phases in order from lowest energy to highest, be solid, liquid, and gas. Example from nature, when energy is lost, the pond water loses energy, it freezes, becomes solid. In the spring, the pond water gains energy from the sun, the frozen pond melts. Are there parts of your graph that look like the graph that is provided? So yes, you should see where water is heating up, the line has a fairly steady slope. Where phases are changing, the line has no slope, or it's flat. 3 sources of error. And so if you did not measure the temperature at specific time intervals correctly, that would be a source of error. If you did not read the thermometer correctly, so sometimes people count each dash as 1, but if you notice, they're really 2 because there's only 5 of them between 10 and 20 degrees and so forth. Not measuring the volume of ice or water at the beginning would be a problem. And then if you were to turn the hot plate up in the middle, or turn it down, or turn it off, that would affect your data. All of them would change the line on your graph that relates time heated to change in temperature. Just some common substances. Room temperature is 37 degrees Celsius. So if I knew that it boiled at 100 and freezes at 0, then it would be a liquid at 37 degrees. And so iron is a solid at 37 degrees, oxygen is a gas, mercury is a liquid, and ethyl alcohol is also a liquid. Finally, when a material reaches the temperature at which the change in state occurs, the temperature will remain the same until all the energy is used to change the state. Once it's changed state, then it can start to change temperature once again. If you have any questions, please feel free to email me. Have a good afternoon. Bye.